I'm Anil Kumar, and in this video we will understand the characteristics of a polynomial, especially the end behavior. As you know, end behavior is dictated by the leading coefficient. So leading coefficient you have to see to decide the end behavior of a polynomial, right? And the other term is, I should say actually, leading term, right? Leading coefficient and degree. Let me write degree. So degree of polynomial. So these are the two things which we have to look into to decide end behavior. Now I hope you understand what do we mean by end behavior. End behavior really means if x approaches negative infinity, what happens to y? If x approaches positive infinity, then y approaches which side, positive or negative infinity? For a polynomial, y will approach to infinity whenever x is approaching positive or negative infinity, but it depends whether it is approaching positive infinity or negative infinity. So that is what we need to decide when we are looking into end behavior. And that has decided by two terms, which is actually the leading term. Leading term gives you leading coefficient and degree of polynomial, right? So that decides. How do we figure out? So we'll divide this page into two parts and we'll discuss both these one by one. So on one side, let us take odd degree. And on the other side, we will consider even degree polynomial. Even degree for us will be like 2, 4, 6, 8, odd degrees like 1, 3, 5, 7 and so on, correct? Now as you know, even and odd degree is one part and second part is leading coefficient. So as far as the leading coefficient is concerned, I'll have to further divide this page into two more parts. And that is to say that we will take leading coefficient as positive or as negative. So the leading coefficient could be positive or negative, right? So these are the conditions which will help us decide what type of end behavior we have. Okay, now let's begin with positive leading coefficient, right? So I'm just sketching possible graphs. Rather end behavior. If the leading coefficient is positive, then whether it is odd degree or even degree, if x approaches positive infinity, that means this side, y will approach positive infinity in both the cases. We say right side up. This is the term I use. It is not a term from the book. Right side up. If the leading coefficient is positive, a polynomial graph will have right side up, ending in quadrant 1. Clear? Okay. Always ending with quadrant 1. Right side up. Now what happens when x is approaching negative infinity? If it is approaching negative infinity, then for odd there is a rule, opposite ends. And for even, same ends or same side. So that means if you are approaching negative infinity and you have even degree, same side means right side up, the other side is also up. Do you get it? Odd degree, opposite end means right side up, the other side is down. Opposite ends. That is the end behavior. Do you understand? If the leading coefficient is positive, degree is odd, in that case, when x approaches negative infinity, y approaches negative infinity, x approaches positive infinity, y approaches positive infinity. In this case, when x approaches negative infinity, y approaches positive infinity for both the sides, right? Okay, that's clear. Now let's get into what happens when we have negative leading coefficient, right? If the negative leading coefficient, then right side is down, right? Then we say right side down. Right side down. That means for both it is ending up in quadrant 4. Do you understand? For both, whether it is even degree or odd degree, it ends in quadrant 4. Okay? But if it is even degree, then both sides are same, so both down. Do you see that? But for odd degree, it will be opposite ends. Do you get the point? In between, it depends on the equation of the polynomial, but that is the end behavior. Now, you can clearly write your end behavior here, right? So here it is if x approaches negative infinity, y approaches negative infinity. If x approaches positive infinity, y approaches positive infinity. This is when positive leading coefficient for an odd degree, opposite ends, right? In this case, if x approaches negative infinity, y approaches positive infinity. X approaches positive infinity, y approaches positive infinity. Same side, do you see that? Both are on the same side. Here x approaches negative infinity, y approaches positive infinity. If x approaches positive infinity, you understand, positive that side, y approaches down negative infinity. And here if x approaches negative infinity, that means this side, y approaches negative infinity. Going downwards, if x approaches positive infinity, y approaches negative infinity, both side down. Do you see that part? That is how you have to understand end behavior of a polynomial. I hope that's absolutely clear and you're not going to forget. So if leading coefficient is positive, right side up. If leading coefficient is negative, right side down. For even degree, same sides. For odd degree, opposite ends. That should help you to get end behavior correct always. I hope that helps. Thank you and all the best.